A very good morning to all my dear students. Let's start today the topic internal resistance of a cell. This is denoted by small r term. Now, along with internal resistance of the cell, there are few more headings EMF, TPD that also we will understand here, and these headings are interconnected with each other. So that relation also we have to derive. So, let's start first of all with the cell description. Students, the circuit symbol, this one, is showing the cell. You already know. This side it is positive terminal and this one is the negative terminal of the cell. The purpose of the cell is to provide potential difference across the circuit so that current can flow. So, it can happen like this, that if we connect the cell through any external resistance R, then current will always flow from positive of the cell, that means high voltage here, and then through the resistance and to the negative terminal. This way the resistance gets the current. Okay. Now here I have taken the name of external resistance. So first of all, let us discuss about this resistance term in detail. See, whatever resistance of the wire is present outside the cell, that we call external resistance. This we denote by capital R. And inside the cell also one resistance is present, that we call internal resistance small r. So, in the symbols, the difference is there. Capital R means external resistance and small r means internal resistance of the cell. Okay, so any resistance which is present inside the cell, that is small r. Now from where this small r has appeared, to understand that, let's take the example of a chemical cell which is usually used in the circuits to provide current. A chemical cell means a positive rod and a negative rod. They are dipped in a solution this way, and the name of this solution is electrolyte. So in a chemical cell, actually what happens here, some chemical reactions take place. Due to that, the positive charge always deposits on the first electrode and negative charge always deposits on the second electrode. So this chemical reaction continuously takes place due to the electrolyte concentration, and positive, this rod always becomes positive and this rod always becomes negative. So this way, because positive and negative charges have been accumulated, so that's why a potential difference is actually created between the 2 points. So this is a high voltage point and this is a low voltage point. So when we connect the two electrodes through some wire, then the rule of the current is what? That current always flows from high voltage, that means from here, to the low voltage point. This way this external resistance R gets the current, which I told you here also. So this circuit is detailed circuit, and in form of symbols we can show it this way. The meaning is the same. From the positive rod the current flows to the negative rod. Okay. Now after this what? That means when the current starts from the positive rod through the external resistance, it reaches here. Now, after this, will there be no current? Okay, so let's think about it. Here, when the current reaches here, then here there is no blank space. Actually, they are dipped in the solution. So, this continuity of the current is maintained. That means current still flows. Current still flows through the electrolyte solution. Okay, so continuity of the current is maintained. through this medium. Okay, what medium? Electrolyte medium. But this current flow is not easier here. Some resistance this current also has to face. Okay, so because this place is not empty, it is not blank, here crowd is there. So whenever we have to go through any crowd, then we have to always face a resistance. The movement is not easy that time. So the meaning is, whenever the current is flowing inside the cell, then also the current has to face a resistance due to electrolyte. So that resistance we call internal resistance. So I think the idea is clear. The resistance offered by the electrolyte of the cell to the flow of the current is called internal resistance. So here is the definition written. You can note down. Internal resistance of the cell is the resistance offered by electrolyte of the cell to the flow of the ions. Okay, that means now this internal resistance is essential part of the cell. Okay, every cell will always offer a resistance. So when we show in the circuit symbol, whenever we show this cell, that means inside this cell always there is a resistance small r. Okay, one small r resistance is always available. Now to make the calculations easier, where to show this internal resistance? So this is shown always along with the cell in series. So now onwards, whenever we will talk about the cell, along with the cell symbol, we will always show an internal resistance small r. Okay. Now on what factors this small r will depend, that also we will discuss. So the internal resistance is the property of the cell itself. Okay. Now we have understood this heading, that internal resistance of the cell is the resistance offered by electrolyte. Now we will understand two more headings of the cell, that are voltages. A cell can provide two types of voltages. Now how the cell can provide two voltages? It depends upon how the cell is connected. So the first circuit which has been shown here, that means only cell has been shown here. So the difference lies in this diagram only. In first case, the cell is not connected with any external circuit. So here we say that cell is in open circuit. And in the second circuit, when the cell is connected through some external resistance also, then this type of circuit is called closed circuit. Now, whether the cell is in the open circuit or it is in the closed circuit, it will always provide a potential difference. Why? You can see, we have discussed before, this side it is positive rod, this side it is negative rod in the cell. So cell means a rod is positive and another rod is negative. And due to that, always there is a potential difference between the two terminals of the cell. This potential difference we call EMF. EMF means electromotive force in detail. Now whether in the detail term force term is coming, but it is not force. Remember students, it is voltage only. So EMF means whatever voltage difference is present between the two terminals of the cell when the cell is in the open circuit. So it is the maximum voltage which a cell can provide. So EMF means E, it is that voltage which is between the terminals of the cell in the open circuit. Okay. Now let us come to the second type of voltage, TPD. TPD means terminal potential difference, or we can call it also terminal voltage. We denote it by symbol V. Here it was E symbol, here it is V symbol. Now TPD means when the cell is in the closed circuit, that time time what is the potential difference between the two terminals of the cell? Okay, so when the cell is open, then the potential difference is E, and when the cell is closed means connected across any resistance, that time whatever potential difference is there, that potential difference we call terminal voltage V. Now how does it happen that E and V are different? Okay, when the cell was open, then E voltage. When the cell is closed, then V voltage of the same cell. So for understanding this case, let us take the example. Suppose a cell, when it is open, its E is, that means maximum voltage E is 4 volt. Now 4 volt means this should be available for this resistance when they will be connected. Okay, but what happens when actual connection takes place? We have seen that a cell has an internal resistance also, and this internal resistance comes into play whenever current flows. So suppose this same cell I have connected through external resistance R now. Here the open circuit was there, here it is closed circuit. So now what happens? Suppose this cell was providing 4 volt like this. Now this 4 volt should be completely available for this capital R. So here also it should be available capital R. But you see this circuit. It is a kind of series circuit in which 4 volt is available for two resistances, small r also and capital R also. So because the cell is not alone when the current flows, cell also shows an internal resistance, and along this internal resistance also the current flows. So some voltage drop IR here also takes place. So suppose this small r takes 1 voltage. Okay, that means the voltage drop across the internal resistance is 1 volt. So from 4 volt, 1 volt is already taken. So that means how much voltage is available for external circuit? So now it is only 3 volt. That means now this voltage which is available for external circuit, that is the terminal voltage. So terminal voltage is coming less. So the idea was what? When the cell is in the open circuit, whatever voltage, that means E, it provides maximum. It should be available for external circuit when we will connect it. But when we will connect it, internal resistance will also appear. And internal resistance always takes a drop across it from the available voltage. So from the available voltage, that means 4 volt or E volt, it takes a drop IR. So for the external circuit, now not 4 volt is available, now some less voltage available. So that now available voltage is called terminal voltage. So if we relate terminal voltage with E, you can see now for this external circuit, terminal voltage is from E, something has been taken by internal resistance. So from E, whatever voltage has been taken by internal resistance, that we have to subtract. So this way the relation among the three has been established. Terminal voltage V is obtained by subtracting IR term from E. So E is the maximum voltage and V is always less. So EMF is always greater than TPD, or in short we can write E is always greater than V. Why it is greater? That we have discussed. Because when the cell is in the closed circuit, some voltage drop always takes place across R. So this way we will obtain this equation. This is very important equation for in case of the cell. Now, if this equation is learnt, and understood. After that, now we are moving to the derivation of small r. One small derivation is there for this internal resistance. Let's proceed to that. So this all you can note down, and after that you can move ahead in the video. Let's start. So when the derivation of small r is asked, we need to draw a cell, and as I told you, a cell is always shown along with its internal resistance. So the cell can provide maximum E voltage. Now small r always comes into picture when the cell gives current. Okay. Now suppose one current I flows through this capital R and moves to this side. So how much voltage or terminal voltage is available for external circuit? See, this portion is only cell, and cell is in the closed circuit because it is giving current. So this voltage which is available now, that we will call terminal voltage. Okay. And by Ohm's law, if I flows through R, then IR is the voltage, and this voltage we will call here terminal voltage. So first equation is, which we have to use, V equal to IR. Second equation is how V, E and small r are connected. So we have seen from this cell, if IR is subtracted, we get V. So using these two equations only, we have to do the derivation. So derivation is what? That we have to derive the small r formula. So using or in terms of E and V we will derive. So it's very simple. Derivation is very simple. What we have to do? Whatever is common term, that means I, that we will find out from first equation, and this we will substitute in the second equation. Okay, so remember these two steps. Firstly these two equations, then one find common equation. So from first I calculated and substituted in second. Now our target is what? Our target is to solve this small r. So what to do? This V by R small r, we are shifting here, E minus V here. After that what? Our target is this small r to find out. So this V by R also should go this side. So you see now we have obtained. So this can also be the last formula, or one more step we can go, E by V minus 1 into R. That also we can write. So this is our final answer. So whenever the derivation of small r is asked, derivation of small r means this small r, how it is connected with E, V and capital R in any such circuit. So you have to give this formula at last. So learn this formula. It is important for potentiometer circuit also, which is the next topic. So E upon V minus 1 into capital R. E means open circuit voltage of the cell, V means closed circuit voltage of the cell, and R means what external resistance is connected across cell. So here we have discussed the complete internal resistance of the cell